Hey, what's up, guys? Welcome to this presentation of the energy market course for engineer John Grimaldo and all interesting audience. We will address a critical view on the limitation of an automatic generation control in the stabilization of the power system in case of increase in load demand. Okay, soon after the 1960, the management power system changed as they began to be managed from command and control centers. Some of the main functions of an automatic generation control are controlling the main generator power, maintaining the system frequency within a preset range, and remote control. Currently, one of the drawbacks that is hitting the electricity sector hard is the inability to reserve or store large amounts of energy. Added to the issue is the fact that large power producers, thermal and nuclear, cannot be regulated. Additionally, but not less important, it should be noted that energy demand over time is quite varied, oscillating between large margins. To summarize the latest, energy demand is highly variable, but there are neither reserves to stabilize the energy flow nor production center capable of quickly adjusting their production to the oscillation in order to meet this consumption. Most power generation plants have interconnection lines with other nearby plants. Interconnection lines allow the sale or purchase of all surpluses and deficits that arise during production, as well as the sharing of generation source of both in emergency situations and under regular operating conditions. This results in a more rational use of resources and a more beneficial economy. Going into a little more context of the frequency change or variation, this occurs because the system load fluctuates uncertainly throughout a day. Thus, it is complex to provide an accurate prediction of the actual power requirement. The instability that arises between actual power generated and load requirement plus losses throughout the frequent period of load cause rotational kinetic energy to be added to or removed from the running generating device, resulting in frequency fluctuation across the interconnect system. As a result, if the actual power generation exceeds the anticipated power demand, there will be a significant kinetic energy surpassing the machine shaft, increasing the speed of the generating device and, in turn, increasing the frequency value. On the other hand, if the actual power generating is lower than the anticipated power demand, the generating units will experience kinetic energy losses in their shaft, which will reduce the speed and frequency of delivery to the system. Okay, more pointedly, the article for which this presentation is made, the observation was made that before the implementation of the AGC, the system as such could not maintain its frequency in its nominal state due to an increase in load demand. Since the frequency fell below acceptable range, we are talking about 49.32 Hz. It is said that the operating frequency range to be accepted should be between 49.5 Hz and 50.5 Hz. However, after including the AGC, the frequency was maintained despite an increasing load demand. However, after a certain period, the AGC began to fail to maintain the system frequency. Similarly, after another lapse with the AGC and with another increase in load demand, it finally managed to stabilize the system. From the above, something similar happened with the energy exchange. The AGC present failures in keeping the system stabilized. Likewise, after several increasing load demand, the system finally stabilized. It should be noted that in certain periods of time, energy losses improved or decreased when there was an increasing load demand. The system was also compromised by decreased in reserve when there was an increasing load demand with the AGC active. With the different throwbacks present throughout this position, certain conventional controllers only prefer shared validation within specific operating range due to the nonlinear properties of the system. With the passing of the days and experiences, great changes in artificial intelligence techniques, fossilized neural networks, and optimization techniques. This type of problems can be solved with the above-mentioned technique efficiently and to such a degree that they become a thing of the past. Artificial intelligence offers high benefits at the time of having it, and more if they are nonlinear control problems, specifically when the system is operating in the range of nonlinear operating. This could be one of the options for which more should continue varied in order to reinforce the generation reserve. One of the cases is renewable energies as an alternative source of supplies in order to have a greater stabilization in the electricity system. However, in order to connect this type of energy resource and adequate integration to the electric system must be considered to prevent any inflows that could be destabilize the system. Okay, thank you for watching and see you soon.